Okay, geometry, let's talk about zoom factors. Scale factors, ratio similarity, linear scale factors, those all mean the same thing. The zoom factor, scale factor, K, we call it K, tells you how much the dilation stretches or shrinks the figure. Stretches, by stretches we mean makes bigger, shrinks makes smaller. Okay, if the zoom factor or the scale factor, they mean the same thing. If it's greater than the 1, then the image will become larger. Makes sense. Greater than 1, larger. If the zoom factor or the scale factor is less than 1, then the image will become smaller. So if it's a fraction, like 1/2, it'll be half as small. If the zoom factor is equal to 1, then the image will be congruent. It will be exactly the same. All right, let's talk about dilation rule. If our original point is xy, to get our new dilated point, we simply take the scale factor k and multiply it by the x coordinate. So that would be k times x, and we take our k factor and multiply it by the y coordinate, k times y. All right, k, of course, is your scale factor or your zoom factor. In other words, you simply multiply. You multiply each coordinate, the x and the y, by your scale factor. Let's look at this example right here. Here, our scale factor is 0.5, so our figure is going to be getting smaller. So here's our big triangle, here's our little triangle. This is the original. Look at this point, 2, 3. If I multiply that by 1/2, half of 2 is 1. And if I multiply 3 by 1/2, half of 3 is 1.5. So my new point would be 1.5, which of course is right here. So this point goes here. Same thing here. If I take half of 3, I get 1.5. If I take half of 1, I get 0.5. So I'm taking each of my original points and I'm multiplying both the x and the y by the scale factor k to get my new point. Let's practice here. Let's say my scale factor is 0.5. All right, so I simply take -2 times 0.5, which will give me -1. And then I simply take 3 times 0.5, which will give me 1.5. All right, again, a scale factor that's less than 1, these numbers will get smaller. Now let's try this. Hey, what if you see a scale factor written like that as a fraction? Same thing. We multiply both the x and the y by 1/2. So half of -1 would be -0.5 or -1/2. And then half times our -2 would be -1. All right, what if we try this point? 60 with a scale factor of 0.5. Again, half times 6 is 3. And half times 0 is still 0. 0 times anything is still 0. Ready? Now let's go over here. What if we give you a scale factor of 4? We simply multiply -2 times 4. -2 times 4 is -8. And if we multiply 3 times 4, that gives us 12. So this point is enlarged by a scale factor of 4. These are each 4 times as big. Alrighty. Now, what if I give you a scale factor of 7? Again, you multiply. -4 times 7 will give you -28 for the new x coordinate. We take the y and multiply it by 7. -5 times 7 will give you -35. All right. Finally, what if you're given the original point is 5, and your new dilated point is 15. What is our scale factor? Well, this is definitely getting bigger. 5 to 15 gets bigger. So our scale factor has to be greater than 1. 5 times what will give us 15? Well, that would be 3. And let's check. Is 0 times 3 still 0? Absolutely. So again, to get your new dilated point, you simply multiply both the x and y by your scale factor to get your new point. Let's look at this example. Our original figure is A, B, C, D, the bigger one in blue. The smaller figure, A prime, B prime, C prime, D prime, is our dilated figure. So our figure is getting smaller. So our scale factor has to be less than 1. So let's look at our point. I'm going to focus on, let's look at point A. Our original point is negative 2, 4, and our new dilated point is negative 1, 2. How do we get from negative 2 to negative 1? How do we get from 4 to 2? It looks like our scale factor is 0.5. All right, oops, that's highlighter mode, of course. Let's just look at one more point. What if we look at B, 4, 4? 4, 4, and then let's look at the new B, 2, 2. It definitely is half. Half of 4 is 2, half of 4 is 2. Our scale factor is half. This yellow figure is half the size of our original blue figure. All right, let's go over here. Let's dilate this triangle by a zoom factor of 2. Because this is bigger than 1, our triangle is going to get bigger. Okay, let's write down our original points. Point A, our coordinate of point A is negative 2, 1. All right, if we multiply those each by 2, negative 2 times 2 will be negative 4, and negative 1 times 2 will be 2. So let's plot the new A. Negative 4, 2 will be right here. There's A prime. Alrighty, now let's try up at B. Okay, the original point B, that coordinate is negative 1, 4. Negative 1, 4. All right, so if I want to go and find my new point, I would multiply each of those by 2. Negative 1 times 2 is negative 2, and negative 4 times 2 would be 8. So our new B would be negative 2, 8. Negative 2 up here at 8 right here. There is our B prime. And finally C. Our C point right here is, our original coordinate is over 2 and up 3. 2, 3. So our new point, C prime, we multiply those each by 2. 2 times 2 gives us 4. And 3 times 2 gives us 6. So the new C would be 4, 6. So over 4 up 6. And there is our new enlarged triangle. There we go. Here's a fun way to check your work. Start from 0, 0. From 0, 0 to our original A, the path is left 2, up 1. We would have to follow the path one more time and get to the second one. Left 2, up 1. If the scale factor is 2, you follow the same path twice. Left 2, up 1. Left 2, up 1. Let's try it with C. To get to the original C, right 2, up 3. Again, do it again. Right 2, up 3. Last one. Let's find our original triangle. Our original triangle is A, B, C. So our original triangle is the smaller one. Okay? And then our bigger triangle is A prime, B prime, C prime. So that is our bigger triangle. I'll trace that up in blue. Okay, our scale factor, our triangle is getting bigger, so our scale factor has to be greater than 1. K is greater than 1, so let's test a point. it's not going to really help us to test A because they're both 0, 0. So let's focus on the B's. Let's find the original point B. The original coordinates for B are over 3, up 4. 3, 4. All right, now let's find the point for B prime, the second B, the new B, right up here. That looks like it's over 1, 2, 3, 4, 5, 6, over 6, and up 5, 6, up 8. 6, 8. Well, how do we get from 3 to 6? That's times 2. Let's check. From 4 to 8, is that also times 2? You bet. RK is 2. That bigger triangle is twice as big. Hey, go try homework 2. Thanks, geometry.